If 24.83 centimeter cube of 0.15 molar sodium hydroxide is titrated to its endpoint with 39.45 centimeter cube of hydrogen chloride, that is HCl, what is the molarity of hydrogen chloride, that is HCl? Solution. In any titrametric analysis question like this, the first thing to do is to write out the chemical equation showing the reaction between the acid and the base. So we have NaOH, that is the base, sodium hydroxide, plus HCl, hydrogen chloride, which is the acid. To give us, we'll be having salt and water. So we have sodium chloride, which is NaCl, plus H2O, that is water. So the next thing to do is to check if the equation is balanced. And looking at the equation above, we can discover that it is balanced. So we have a balanced chemical equation. So let's proceed. To solve this kind of question, the formula we'll be using is CaVa over CbVb to be equal to Na over Nb, where Ca is the concentration of the acid, also known as the molarity of the acid. Va is the volume of acid used. Cb is the concentration of the base. Vb is the volume of the base, while Na and Nb is the number of moles of acid and base used respectively. So next thing to do now is to write out the data given so we can identify the unknown from the question. So from the question, we have our Ca. What is Ca? That is concentration of acid used. The molarity of the acid is unknown. So we have Ca to be unknown. Volume of acid used, Va, we have 39.45 centimeter cube. Then the number of moles of acid, so that is the number, that is the coefficient in front of the acid used here from the equation, which is 1. So we have Na to be 1. Cb, concentration of base used, is 0.15 molar. So from the question, the volume of base used, Vb, is 24.83 centimeter cube. And the number of moles of base is 1 as well. That is the coefficient of the base in the equation. Having done this, we make Ca the subject of the formula, because from the question we are asked to calculate the molarity of HCl, that is the acid. So to know the concentration of the acid, we say Ca equals Cb Vb Na all divided through by VANB. So let's substitute the values. Ca is then equal to, our Cb is 0.15 molar multiplied by Vb 24.83 centimeter cube. Then the Na, that is the number of moles of acid used, is 1, all divided through by the volume of acid used, 39.45 centimeter cube. Multiplied by the number of moles of the base used, which is 1. we have 3.725 molar divided by 39.45, which is equal to 0.094 molar. So here we've calculated the concentration of acid used, which is same thing as the molarity of the acid according to the question given. So the molarity of HCl here is 0.094 molar. And that will be all. So we've answered the question. Thank you.